In Lecture 11, we're going to take a broader and deeper look at the C++ standard library container classes, and also a deeper look at iterators for traversing through these various containers. Probably the most commonly used of the standard containers is the vector. Basically, a vector is a better behaved array. Unlike an array, the vector can grow and shrink on the fly, and it provides member functions that we can call for finding out how large the vector currently is, how large the vector could possibly be, and so on. It does store, just like an array, its elements in ascending contiguous memory locations, so the same kinds of algorithms that we used either subscripting through an array or using a pointer to step through the elements of an array, we can also use with vectors. A vector is guaranteed to be properly initialized. If you declare a vector object with no initialization information, then you get a properly configured empty vector. And there are many different constructors that can be used for initializing the contents of a vector in a variety of different ways. We can do direct equality and inequality operations and assignment. We can also do relational comparisons of vectors, less than or equal to, and so forth, and we'll see an example of that shortly. Of course, we can do subscripting to access an individual element using the square bracket notation, but we also have the ability to use iterators to traverse through vectors, which allows us to use standard algorithms that can be applied not only to vectors, but to many different kinds of standard containers. Now, unlike a conventional array, we can, in addition to growing and shrinking the vector at the back, we can also, although this is expensive, we can insert an element into the middle of a vector, we can remove an element from the middle of a vector, and we can also replace a set of elements in a vector with some other elements. Let's take a look at some examples of this, starting on slide 3. Here we've included IOStream as usual. We've also included vector, which we need for the vector container class. And we're showing here a variety of constructions of vector objects. First, IV is a vector of int, which is initially empty. IV2 is a vector of int. Notice that we've given an integer in parentheses. That invokes a constructor that builds a vector of that length. And here we're getting the default value, which is 0 for ints, for each of the elements in that vector of 4 ints. In IV3, we're specifying what value we want for each of those elements of the vector. So IV3 is again a vector of 4 elements, but this time each element is initialized with a 7 instead of with a 0. And then, of course, for IV4, we're using our initializer list to specify that we want IV4 to be a vector of 6 ints, specifically 1, 2, 3, 9, 8, and 7. We can assign one vector of int to another vector of int. So IV was empty, and now IV contains a copy of IV4. That is, it contains the 6 elements 1, 2, 3, 9, 8, 7 that exist in IV4. Here we're invoking for IV5 yet another constructor. This time it's a constructor that takes a vector of int and builds a new vector of int, in this case IV5, from the existing vector of int, in this case IV. Alright, continuing on slide 4, here we're doing a relational comparison between IV2 and IV4. Now, IV2 contains 4 0 elements. IV4 contains 6 elements, 1, 2, 3, 9, 8, 7. What the relational test does is an element-by-element comparison, and the first time when a pair of elements are discovered that don't match, if the one on the left is less than the one on the right, we're going to consider the entire vector on the left to be less than the vector on the right. So we first compare the 0 that's in IV2 sub 0 with the 1 that's in IV4 sub 0, and because the 0 is less than the 1, we conclude that IV2 is less than IV4. Now, is this the right way of doing a less than comparison? Well, it's the way that was chosen for implementing the vector class. Likewise, in this next comparison, we're testing whether IV3 is greater than IV4. Now, IV3 has a first element of 7. IV4 has a first element of 1. So in this case, we conclude that IV3 is greater than IV4 because the 7 is greater than the 1. In the next part of the code here, we're using our old pal, the range for loop, to step through the elements of the vector IV and display each element one by one. Each element followed by a space is going to be displayed, and then we're displaying a new line character when that's finished. So what we're going to get out from this range for loop is 1 space, 2 space, 3, blah blah blah, space, 7 space, and then a new line. Now notice in this next range for loop that instead of using an int as our element type, we're using a reference to int. Now this means that EL refers to each element in IV one element at a time, as opposed to being a copy of each element in IV one element at a time. So here, when we say EL times gets 2, that is actually directly modifying the element stored in IV. So initially, the first time through this loop, EL is going to be referring to IV sub 0, which contains a 1. And when we multiply that by 2, IV sub 0 becomes a 2. Next time through the loop, EL is referring to 2. We multiply that by 2, and EL sub 1 becomes a 4, and so on. So when we then loop through IV a third time, displaying the elements that are in IV, what we're going to see is that the elements have all doubled. They used to be 1, 2, 3, 9, 8, 7. Now they're 2, 4, 6, 18, 16, 14. So this business of using a range for loop with a reference parameter is very useful. Okay, so that's just a quick look at some mechanisms for constructing vectors, assigning vectors, comparing vectors, and looping through the elements contained within vectors. Next, we're going to take a little bit deeper look at iterators. An iterator is a generalized kind of pointer. Now, what do we mean by a generalized kind of pointer? What we mean is that the syntax for interacting with an iterator is pointer-like syntax. That is, we can do star on an iterator to access the value that the iterator, quote, points to, unquote. We can do plus plus on an iterator to increment the iterator to point to the next element, and so on. Iterators are used in containers not only for looping through, but also for specifying locations in containers where you want to insert a new value or where you want to erase a value. They're also used in what are called standard algorithms. This gets at what we call generic programming, where we can write an algorithm that uses iterators, so the algorithm doesn't even need to be aware of the implementation details of which kind of container it's operating on. That is, we can shuffle the elements in a container through iterators, whether that container is a vector or a list or something called a deck, a double-ended queue. And furthermore, we can shuffle the elements, whether those elements are ints or chars or strings or pointers to employees or any other kind of copyable data.